Welcome to a new video. In this video we will see the common logarithm and the natural logarithms. Common logarithm is a logarithm that has 10 as a base. So if we see something like logarithm of x, okay, then we cannot see any base here, but actually there is a base which is 10. So that expression is called logarithm of x is called common logarithms in this case. Here the x value should be, because logarithm is a function, that function is defined from all positive real numbers to all real numbers. In other words, x value has to be equal to a positive real number. So as an example, we can say that logarithm of 5 means logarithm of 5 in base 10, or logarithm of 1 means logarithm of 1 in base 10. Actually this is only the 0, we already know this. And other kind of logarithm is called natural logarithm, which is abbreviated as ln. Okay, and as we can see here, logarithm of x in base a is called natural logarithm. In other words, if the base of any logarithm is e, and then that logarithm is called ln x. And we all know that e is a constant. It is 0.7 and goes to infinity. So this is a positive real number. So when we say that ln 5, that means this is equal to logarithm of 5 in base e. When we say, let's say 2 to the power of logarithm of base e 5, and this is equal to 2 to the power of ln 5. When we say e to the power of logarithm of 7 in base e, this is equal to, guys, e to the power of ln 7, and this is 7, guys. This we already learned this property from our previous video. So we can say that, okay, from this point of view, if we have something like e to the power of ln 10, this is 10, guys. If we have something e to the power of ln 100, this is 100, guys. And now let's take a look at examples. We have logarithm of x is equal to 4, and in this case, what is the value of x? We don't see any base written in the logarithm, so that means actually the base of the logarithm is 10. Okay, so logarithm of x in base 10 is 4. This is the question actually. And from here we all know that that 10 can go to the right side as a base, and that 4 comes as a power to that 10, and in the left part that x comes down as it is. So x is 10 to the power of 4 in this case. And let's continue with the next question. And now in this question we are asked to find the value of x again. Of course we need to start from the very outside of the expression, which is logarithm in base 3. So that just send this 3 to the right. It's going to be 3 to the power of 1, and as we know that 1 comes to that 3 as a power. So just carry that ln x to the downside as it is. So it's going to be ln x is equal to 3 to the power of 1. In other words, ln x is what? Logarithm of x in base e, and this is 3 to the power of 1, which is 3. So that is equal to 3. And again we're going to apply the same thing. Okay, that e comes to the right as a base, and that 3 is going to be the power anymore, so it's the right side is going to be e cubed, and x is on the left. So as at the beginning it looks like a difficult question, but actually it is an easy question. So we found out that x is equal to e to the power of 3. And let's continue with the next question. In this question, x is given to us as logarithm of 35 in base 2, and y is given to us as logarithm of 12 in base 3, and z is given to us as logarithm of 4 in base 5. So we are asked to put the x, y, and z in order from greatest to least. So which one is greater and which one is smaller? So we see that x, y, and z values, these are the rational numbers, so they are not integers. Why? Because if x was, let's say, logarithm of 32 in base 2, and we could say that, okay, that x is an integer. How? Because logarithm of 32 can be written as 2 to the power of 5, and the base is 2. So from our previous examples, that 5 can come to the front, so it's going to be 5 times logarithm of 2 in base 2 is 1, so we would say that this is equal to 5. But that 32 is not the number that we have in x. X is given as logarithm of 35, so this is not x, by the way. So if the number would be, okay, if x is, let's say, logarithm of 64 in base 2, we would say that from the same logic, this would be a logarithm of 2 to the power of 6 in base 2, and that is 6. Okay, so because that 35 is somewhere between 32 and 64, that x is somewhere between 5 and 6. So just let me write it here. X is something between 5 and 6, let's say 5 point something. So we know that for sure x is greater than 5, but also that is less than 6. From the same point of view for y, we could say that y is logarithm of 12 in base 3. If that 12 would be 3, the question would be logarithm of 3 in, let's make it 9 instead of 3. If that would be 9, 9 is 3 square, right? So that would be 2, and then that would be 2. But it's not 9, it's greater than 9, it is 12. If that would be 27, then y was going to be equal to 3 in this case. So y is somewhere between 2 and 3 in this case. Let's say y is 2 point something. Okay. And from the same point of view, z is given to us, just let me write it here, z is given to us logarithm of 4 in base 5. If that 4 would be 5, logarithm of 5 in base 5, and the result would be 1, right? This is 1. If that 4 is 1, logarithm of 1 in base 5, which was 0. So because 4 is between 5 and 1, z is between 0 and 1. So we can say that z is 0 point something. Okay, from this result we can conclude that z is 0 point something and y is 2 point something and x is 5 point something. So if we put them in order from greatest to least, we can say that x is greater than y and that is greater than z as well, and that is the final answer. And let's continue with the last question that we have in this video. In this question, the first logarithm is given to us as logarithm of x in base e is equal to 2, and the logarithm of y is given to us as 2. So in this case, by using those two logarithms, what can be the result of x squared plus y squared? So we need to represent x and y in terms of some numbers so that we can write x squared and y squared as a rational number or any kind of real numbers. So we can write x squared plus y squared as real numbers. So from the first given term, let me write it here. Logarithm of x in base e is 2, guys. I'm gonna apply the basic logarithm rule. Just send this e to the right, okay? So take x down as it is. X is e squared. That e was coming to e as a power, if you remember. So we can say that x is e squared. So we are asked to find the value of e squared because x is e squared in this case. And let's take a look at y from the second given term. So if we say that we already learned that if there is no any base, like we have in logarithm y is 2, then there is a hidden base actually, which is 10. So logarithm of y in base 10 is 2. Just apply the first rule of logarithm. So y is going to be 10 squared in this case. And if we put y, which is 10 squared, instead of here, okay, and then the question becomes 10 squares square. And if you remember the powers and exponents subject, if you take the power of the power, you need to multiply the powers. So e squared square is going to be e to the power of 2 times 2 plus, from the same logic, 10 to the power of 2 times 2. So the first term is e to the power of 4 plus, from the second term we have 10 to the 4th power. So this is the final answer, guys, which is x squared plus y squared. That's it for this video, and we will continue to take a look at other subtopics in logarithms. Thank you for watching, and hopefully see you guys in the upcoming videos.